लग रही तो एक एंगल पे देंगे बस नहीं इसकी तुमने भी कोई नोमान की शक्ल दिखा देना वो सोच रहा था मेरे क्या
कल्पेश आमच्या एचओडी डॉक्टर नम्रता मॅम जॉईन करतायत एक 5 मिनिटात आपण स्टार्ट करू.
हो, चालेल चालेल सर, काही अडचण नाही.
Dinesh sir, good morning. Hello. Lakshman sir, good morning.
Good morning, everybody. Good morning.
Babu sir, good
Good
morning.
morning.
Sima ma'am,
Good
good
morning.
morning. Good morning. We will start.
Morning, sir.
I'm just checking.
Good morning, everybody.
Good morning, sir.
Dear student, good morning all.
Good
Dear
morning,
student,
sir.
yes, if you have any question, you can raise after completion of sir's session. Dinesh sir, good morning.
Good morning, Milind sir. Good morning, everybody.
Sir, can we start?
Yes, Milind sir, please go ahead. And thank you, sir, for accepting our
हाँ अभी
invitation.
यही फोन के साथ लगा देती हूँ रुक जाओ तनिक
Okay, thank you,
Yes,
sir,
ma'am.
for thank you,
Namrata
sir,
ma'am, good
for
morning.
thank you, sir, for accepting our invitation and for delivering this lecture for our students, sir. So, Milind sir, we can just start. Not a problem.
Namrata ma'am, good morning.
सर
Dinesh sir, we will wait for Namrata ma'am and we
Morning,
will
ma'am.
start. कल्पेश सर एक 2 मिनट के लिए then we will start.
Sorry. No worries.
पूनम राजू
Milind sir, Namrata ma'am has reached college, but I think we can begin and she'll join midway.
Kalpesh sir, can we start?
Yes, sir. Yes, sure.
My audio is clear? Anyone say can yes?
Yes.
Good morning, student. Today's our guest speaker is Kalpesh Pramodghar. He is currently pursuing PhD in physics from Department of Physics, University of Mumbai, India, and he's also network fellow of High Altitude Observatory NCAR, Boulder, Colorado, USA, and I will explain about the what are the achievements of. Can you hear me? Is selected for award of Newkick Fellowship 2024 by High Altitude Observatory National Center for Atmospheric Research NCAR Boulder, Colorado, USA. Also selected for NASA's Heliophysics Summer School HSS program in 2024 at the UCAR campus, United States of America. A Cosper Award by Outstanding Article by Young Scientist. Again, he is selected for Young Scientist Award in Advances in Space Research Journal. Also awarded for travel grant for NASA to visit NASA and doing some research work at NASA. Also selected for visiting research scholar for short-term PhD project at Space Physics Lab, Vikram Sarabhai. Also selected for award of DSC Inspires Fellowship from the Department of Science and Technology, Government of India for pursuing research career which is related to space. Also qualified SET exam, GATE exam, Air 784. Got selected for PhD position in IIT Varanasi. Again got selected for DSC Inspire scholarship for higher education of Government of India on the basis of HSC board merit. And there are different paper publications published in which is related to astronomical area, that is exploring particle acceleration dynamics in vicinity of the ISME shocks. And there are more than 20 plus international and also conference proceedings. And now today he will focus on what are the opportunities in space science. Okay. And during, dear student, during entire session, please mute your mic. And if you have any query or any question, you can raise after the completion of his session. And now I requesting Kalpesh, you can proceed for today's session. Thank you.
Thanks, everyone. Thanks for this detailed introduction. And specifically, I would like to thank Dr. Mivin sir, who has given me this opportunity to present my work, present or introduce all the field here among all the graduate, undergraduate students. Uh, yeah, thank you for all. I should start with screen sharing. Is it visible? Is it on full screen mode?
Yes.
Yeah,
Now
yeah,
is
yeah.
it
So, yeah. So the topic
So
is
it's not on full.
I think is it on full screen because I have
Yes, we
opened
can
another.
hear.
Yeah, yeah.
We can hear.
Yeah. So, uh, yeah, it's all about the introduction to the solar wind, magnetosphere, ionosphere coupling, and its significance in a space weather, the one of the part of the space sciences. And I'm giving the introduction a brief, not delving it into all my own research, but will speak a lot about the upcoming opportunities as well as the current opportunities that are there in the field of space weather as well as the space sciences. So thanks for the introduction. As sir mentioned, I am the Newkirk Fellow at High Altitude Observatory, National Center for the Atmospheric Research, that is NCAR, Boulder, Colorado, Colorado state of a beautiful mountain. Our lab is situated at the just foothills of this mountain. And as well, I'm a DST Inspire Fellow at Department of Physics, University of Mumbai. Let me introduce what mean by DST Inspire Fellow, because one of most of the people, I think from you might have an Inspire scholarship there that starts from your first year of BSc. So after you're completing the scholarship of 5 years, you can upgrade it as a fellowship, and it continues for the whole your PhD study. So if anyone you have any kind of inspired scholarship there, you have a great chance to pursue a career in a physics or any kind of sciences, rather chemistry, mathematics, any basic sciences. So yeah, I will speak a lot about that after, and feel free to ask any question either in English, Marathi, Hindi, because I'm just watching me as you there sitting a 5 year back or 5 to 6 year back, a person coming from Chiprun, Ratnagiri, a part of Konkan, traveled here in Mumbai, sitting there and has bothered about his English. But I will encourage you to be speak. Please speak in Hindi, Marathi, any kind of language. I will answer you. So before going to in detail, I would just like to say, yeah, I'm grown in a rural area, so I have influence of these Marathi literature, and there is our son Tukaram says, "माझे आप मी पणावर पडो पाषाण जळो भूषण नाम माझे." Whatever sir has told about me, just forget about it. Whatever I'm sharing now, whatever I'm presenting now, is just belong to the all researcher or the teachers, all the mentors that have guided me, and all the beautiful and wonderful
अल्पेश,
colleagues that I have.
मध्ये मध्ये आवाज जरा जातोय.
Jatoy?
हो,
Hello?
मध्ये मध्ये जरा आवाज ऑडिओ लो होतोय.
Okay, so sorry. My I will check whether my internet connection is there. Yeah, it's absolutely good.
Okay, okay, no, you can.
If anything is there, please bother me. I can share again. Don't worry. Fine. Is it audible?
Yes, sir. Yes.
Yes,
Yeah.
yes, yes.
Yeah. So yeah, it's whatever I'm sharing, it's all belong to the researcher, teachers, mentors, and my colleagues. Special thank to Dr. Anil Raga, who is my PhD advisor here in Mumbai, Professor Bill Lotko, a renowned scientist here at NCAR, with whom I'm working, Ankush Bhaskar at VSSC ISRO, Zubair Sheikh at UC Berkeley, Kevin Pham at my institute, Slava Markin at John Hopkins University. Omkar, he is my colleague and currently he is in Italy pursuing his postdoctorate, and all other my PhD mates and master students. So, yeah, I'm coming from all this medieval poetry to the contemporary, or I can say a kind of Gen Z word. I know all of the students, you might see this and you might know this. This is called as a Magnemite. Uh, Pokemon that is a famous part of a Japanese anime called as a Pokemon, and there is one nice episode there in specifically. Hello, sir. Am I audible?
Yes, sir. Yes, sir. Absolutely.
Yeah.
Yes, yes.
So there is one episode, What's Your Name, Francois? So these Magnemites, these are the Pokemons, and they have a special characteristics. They are magnetite, and so they are responsible for the electromagnetic signals. And and uh, and one day it's happened something weird, and they behave something weird. They were emitting a wrong signal, they were behaving weird, so everything was chaos there in that particular city. So people were wondering why these things are happening, why these magnemites are doing such weird things. Then it is observed that there is something, a wrong signal from a spacecraft. There is a wrong signal from the satellite that's coming there in that particular city of Japan, and they are influencing on these magnemites. And later, a one person or a one scientist among that Pokemon group, he observed that this is happening due to some of the storms that are happening there on the sun. Due to that, we are facing these kind of things. We are facing this satellite disruption, and that's why our magnemites are behaving such weird. So I think this is a story by anime, imaginary story, but anyone of things that does the same things happens there in the real world. Yes. If you see here, I am just playing this movie and look at the carefully. This is our Earth, and this is a chain of satellites that currently revolving around the Earth. A lot of satellite, including commercial satellite, communication satellite, agriculture, educational, space-based, research-based, science-based, a lot of satellites that are revolving currently around our Earth. But that's not alone. If we go in detail, our Earth is also surrounded by one structure, and that is a fluctuating. You will see some cavity there, and it's continuously in fluctuating in dynamics. So everything, every charge particles, every magnetic field is fluctuating there, and it has some effect on that satellite. So this is a nice movie, or we can say a animation that been made by JHU APL. JHU means John Hopkins University Applied Physics Laboratory. The CGS people, and they made because there was one such event had happened in May 2024, which disturbs few of our satellite, few of our ground stations, and it's just a movie. How that happened, how that has changed our magnetosphere. You will see continuously things are happening there. You will see something is coming there in a particularly things. These are the particle, and they are coming from the night side. I will explain it. What is that? What is this cavity? How what are these string? What are these things are doing there? But before that, we will look a detailed look at these news. These are the n number of news were featuring about the effect of such solar storm on Earth satellite. Not only a satellite, there in 1989 there was a major power grid failure that happened in Quebec, Canada. People were stuck in a lift. People were stuck at a night, and that thing happened. And before that, there was one event in 1889 where a Carrington event, where particularly a large storm happened. Everything got burned. The telegraph wire were connected. They were off. Still, that telegraph machine has been burned. So it was a havoc. And these two are not a sole example. There are a lot of examples where a solar flare or a solar storm disturbs our GPS system, disturbs our power grid. Some of the currents has been gone from the railroad. So these are particular evidence, and you will see a lot of things there on this particularly on this website. So all these things are known to be as a space weather effect. Like we have our own terrestrial weather, our whole space has also some kind of weather. And all these things are called as space weather disturbances. And we will look in detail into it. What are they? How the space weather is different from the terrestrial weather, but these are called as a space weather. There is a threat to our all space-based and ground-based electronics. And the threat to our electronics, the threat to our satellite is the threat to our own life. Currently, the GPS is not only useful for tracking a favorite restaurant in Mumbai, in Bandra, but it's been used by military purposes, lot of automation purposes. You might heard about lot of automated cars. Been recently, a Tesla has launched their car. It not been automated, but they had launched. So their automated car are based on the GPS, and if 70 to 90-meter error has been happened, it will create some accident. And not only the car, that the farming in US is based on GPS. They have all automated systems. They have all things based on the GPS. So everything is there, is affecting with this sun's activity. So the space weather is the effect of solar transient on our space weather. So how this space weather differs from our terrestrial weather? Here is one comparison. On the left side, you will see a terrestrial weather, the aspect of our daily life weather, including rain, cloud, and all. And on the right side, it's about a space weather. Like we know that the sun is a basic fundamental unit behind it. It's a weather engine, either for the space weather, either for the terrestrial weather. We know that sun hits our surface that drives wind, cloud, storm. Similarly, in a space, sun emits radiation, charged particle, as well as magnetic field that disturbs our space. Similarly, like there are atmospheric winds, they move the system around the Earth, where in a space there is a solar wind, continuous stream of electron, proton, and charged particle that bombards on our space. We have a Earth atmosphere which protects us from the harmful solar radiation and the weather extreme. Similarly, we have a magnetosphere. Our Earth has a magnetic field and it has a magnetosphere which protects our Earth or protects ourselves from this cosmic radiation as well as solar radiation. We might heard about or we might saw a lot of lightning there. That is a visual representation of our Earth atmospheric phenomena. Similarly, the countries which are on the polar region, that is on the high latitude region, they observe these auroras, a beautiful auroras with the colors. I will show you some picture that been captured by me. But this aurora effect is specifically at the higher latitude, specifically around the Norway, the countries in US, Europe. There are few events where the aurora has been observed in India, specifically at our northern parts, Ladakh. So yeah, this is the aurora. This is the visual representation of lightning, and and specifically, as we know, the storm alert help us to prepare with umbrella to avoid travel. The space weather alert us to help us or to protect us, our satellite, our astronaut, our power grid system, and everything. So how this sun earth connection is there? The sun, he is here, the earth is here. You will see some kind of structure that we called as a magnetosphere, and there is an interplanetary space between it. You will see a lot of nomenclature here. This part is all about the structure of sun, where sun is has a three cores: inner core, radiative zone, and the convection zone, and the photosphere, which is a outermost part that we see. And then after there is a part which called as a corona, that is a sun's atmosphere. And from that sun's atmosphere, the plasma, let me introduce what mean by plasma. You know that the plasma, you might heard in a school that the plasma is a fourth state of matter, and might heard in a school, and you might see everywhere the burning, the lightning is everything is a plasma. But if you talked about the universe, whole universe, there is a black matter, there is dark matter, and the visual matter that is there. The 99% is in the realm of plasma, including our sun, star, and space, and everything, and a little part of our visible matter that we all are. So 99% of the visible matter is plasma. The plasma is a fourth state. It is a gas of a charged particle that radiates, and sun is made up of plasma. And some of the sun's part get emitted from its outermost part, and it called as a coronal mass ejection. Means it comes from the corona. People say it's come from the corona. That's why it called as a coronal mass ejection. And when it travels in the interplanetary space, it become a part of interplanetary space, and it just takes our Earth. This diagram is dimensionally so bad. Means our Earth is not like this much as comparison to the sun. It's like a small spot, and a magnetosphere hole is like my cursor, and the whole sun is a big one. So that's unfortunate, sorry. but but this is a magnetosphere interplanetary space, and whatever I am talking about is just interplanetary space, magnetosphere, ionosphere, thermosphere system. I'm not a solar person. I'm not a solar physicist. I'm working in a space weather and specifically in a magnetosphere, ionosphere, thermosphere system. I will explain what it is. So there are some basic prerequisites, means not all important, but if I tell something in RE, that means a radius of Earth. That's a unit all the magnetosphere people use to describe a distance in a magnetosphere. So one RE is 6,400 kilometers, and we take that our basic unit as a one RE. Then one astronomical unit, the people who work in interplanetary space use this unit as a, means it's like a distance between sun to earth. We keep it as a one astronomical unit. Forget about the L shell parameter. If I talked about B, then it will be a magnetic field. If I note E, then it will be an electric field. C match and DST are the indices, like how we measure a rain here. It's in centimeter, or it's inches, or it's in millimeter. Same time, a C match and DST are some indices that gives us idea about how intense the storm, how intense the disturbance was. IP means interplanetary, IMF means interplanetary magnetic field. Dawn means early morning, dusk means evening. So dawn dusk is like sakal sandakal, what we talk in our Marathi, or subha sham. So dawn and dusk. So these are some basic prerequisite. You might heard it in further. So let's take a look at a magnetosphere. You all know that there are the magnetic field lines around a bar magnet. They are symmetric somewhat, like, means if you see they go for north pole to south pole, north pole to south pole in a both direction. But due to the continuous flow of the solar wind, uh, our magnetosphere or our Earth's magnet behave different. It's like a compress at a day side, because from the day side it's everything coming from the sun, and it extend along the night side, and it extend along the 300 RE, 300 times the radius of earth at the back, and at the front it's like around 10 to 15 RE, 10 to 15 radius of earth. So that is a magnetic cavity around our earth. We called it as a magnetosphere. And in our magnetosphere there are a different plasma environment. There are different charged particles. Some charged particles are so energetic, so we called it as a radiation belt. You might see that movie called as Mangalyaan, and there is one particular scene there where they celebrate when their Mangalyaan or their rocket crosses the radiation belt, because this radiation belt is a high energetic charged particle. So population of high energy as well as low energetic charged particle is there. So that's why it's quite a threat, or it's very dynamics for the satellite and everything. Then after that, there is a plasma sheet, Bosch-shock, magnetopause. Forget about this thing. Just understand that the magnetic field, the magnetosphere is like a cover, is like a shield to our Earth from the cosmic radiation, from the whatever coming from the sun, from the cosmic rays. So it is a protective shield. It is differentiated into outer magnetosphere, inner magnetosphere, according to, because this every part of this magnetosphere has a different plasma environment. So there is a lot of research based on each part. Means I you if I you means you will be surprised. There is a whole conference of whole conference just based on the radiation belt there in US, where the people across the world come there, talk about the radiation belt, scientists, science, and everything. There are few conferences which talks about the magnetotail, that is a night side part of the magnetosphere. Some talk about the day side part. So every part is a whole branch of science. Every part and everything, the field that I am talking about, it's just a 50 to 60 to 70 years old. Still we we are keeping our basic strongs. So the current, a lot of research is currently going on. So like that, I explained there are a lot of charged particles there. You know that the current, the basic definition of current is a flow of charges. So if a wire is there, we assume that we not assume, we know that the electrons are moving there, and that's why the currents get generated. But in a magnetosphere, there are a lot of particles, and they also have in motion. And when they are in motion, they are charged particle, so they also create some kind of current. So there is different type of current systems that are there in our magnetosphere. For example, there is one current which revolves around our equator. Means if like the earth, it rotates, or the if this is like earth, it's take a ring around the earth, so that's why this current is called as a ring current. That's the flow of ions around the earth. Then there is a magnetopause current, the current that moves around the magnetopause, a front part of magnetosphere, we call that as a magnetopause current. There, the current which moves in a tail of a magnetosphere, we called it as a tail current. And the current which comes along with the magnetic field, we called it as a field aligned current. So there are different type of current, and all these kind of current when flow, if we know or if we brush up our basic Faraday law or basic Ampere law, that moving current generate a magnetic field, and that magnetic field interacts with our earth magnetic field, and it has a lot of effect. So these current system, these currents, they are flowing in our magnetosphere are important. So as I explained about a magnetosphere, there is another part just lower to the magnetosphere. We just came to like structure. We just introduced sun, then interplanetary space, then the magnetosphere. We are getting close towards the Earth. The magnetosphere is the outermost shell, and the ionosphere thermosphere system. It is a part of our atmosphere. Means this is the ionosphere and thermosphere system is known as a region where the atmosphere meets the space. After the ionosphere or through the ionosphere and thermosphere, there is a space. So it's a region, and you might heard in school, you might heard about the atmospheric layers like troposphere, stratosphere, mesosphere. After that, there is a thermosphere and the ionosphere. So ionosphere and thermosphere is known to be a upper atmosphere of the earth, and it is between 80 to 600 kilometer. It is there are the highly charged particles, the temperature is so high, and that's why it is called as a thermosphere. And you see there are few things, means these ionosphere thermosphere systems helps us helps us in a lot of ways. Means our satellites moves through the thermosphere. The We know about the skywave propagation. I still know in the 12th there is a chapter, because I taught 12th science back during my initial days of PhDs, and I know about the skywave propagation, ground waves propagation, and space wave propagation, where you know that in a skywave propagation, particularly a signal which hits ionosphere, thermosphere, and again it's come back to its receiver. So this ionosphere, thermosphere is important one in our communication, in a local broadcasting. So everything if happens in ionosphere, thermosphere due to the sun's activity, it affects our radio propagation, and that's why during the solar flare is coming, people call that, oh, it's a radio blackout. For a particular region, there might be a disturbance in a radio signals. So yeah, this is all about the ionosphere thermosphere system. So there are a lot of neutral particles there in a thermosphere, and you know that the extreme ultraviolet light or solar X-ray, they come from the sun. They ionize that particle. ionize that neutrals. What is mean by the ionization? You know, the basic definition is removal of electron from any atom, and the conversion of it into a ion is called as ionization. So these particular neutrals get the energy from the solar UV or X-ray, then their electron gets excited, they just go out from the atom, and then the ions and the electrons are created, and they are being there in a ionosphere. They are still there. Electrons and ionosphere, they are coupled together for particular part. They are decoupled, means coupled means they are staying together for particular part. They are decoupled. They are away from each other, and it's everything is happening there in a ionosphere thermosphere system. So everything that now I have explained, they are working one by hand by hand. The every response is a coupling, means though the sun is a driver, it drives the magnetosphere, it disturbs the magnetosphere, then magnetosphere disturbs the ionosphere, but ionosphere also gives response to the magnetosphere. So whole the thing, excuse me, yeah, sorry. Yeah, the thing that we called is a solar wind magnetosphere ionosphere coupling. Everything couples with everything, and it's so complex. So, how the things are happening here means how particularly solar wind or a solar magnetic field interacts with a Earth magnetic field. You will see a nice animation there from left side, and the phenomena that's happening there, people called it as a magnetic reconnection. It's quite hard to understand what's the magnetic reconnection, but the magnetic reconnection is like when two oppositely oriented magnetic field they come together, then there is an annihilation of magnetic field. The magnetic field get break, or they change their topologies, and the plasma which flows in our magnetosphere, you will see a pictorial diagram how the things happen. You see one when the magnetic field from the sun, it comes and it's come close to the magnetosphere. You see then the whole magnetosphere with magnetic field get dragged at a night side, and then you will see again there is a magnetic reconnection happening there. You will see in the diagram as well. Then hold the magnetic field again come back. So it's a cycle. People called it as a Dungy cycle. In 1969, Professor Dungy comes with this idea, and that's all people know this whole cycle as a Dungy cycle. That's the interaction between the solar wind and the magnetosphere. And when the things has happened, the reconnection things are happened, you will see a lot of magnetic field, it's coming there. So along with that magnetic field, a lot of charge particles are coming there, and that charge particle get embedded in our ionosphere. So like the whole magnetosphere has their own current system, ionosphere also has their own current system. And I don't want to go in detail of that. I don't want to make your confusion more. But keep or understand that there is something complex that drives that comes from the sun, which hits our magnetosphere, then then inside our magnetosphere, our Earth, and a layer of ions are there, that is the ionosphere, and all these things are happening there, all the coupling processes are happening there, and it's so complex. So this is one of the part of my study, to study this ionosphere to solar wind magnetosphere ionosphere coupling. And 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 there is a phenomena called as a geomagnetic storm. For a particular time period, when this particular structure from the sun hits our magnetosphere, there is a decrease in our magnetic field. And when that structure passes, that goes, that our magnetic field again recovers. And this particular phenomena is called as a geomagnetic storm. And there are a lot of means there are basically two three ways to study this storm. One including satellites and ground based observation. Satellites are there in interplanetary space, they measures the magnetic field. And another thing is a modeling and a simulation. What mean by modeling and simulation? We know that everything happens problems in the base or in the construct of equation. We solve these equation and we have our own earth in our computer. We bring a solar storm from the sun. We just do an experiment there on our supercomputers, and I will see the I will show you the results of that particularly. So the basic introduction or the basic fact behind is the geomagnetic storm or the geospace storm, which disturbs our magnetosphere. So like I explained, there are different satellites like that. There are different models, and one of the famous model that I am particularly using for my studies is a MAGE model, and 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 you see there are the aurora observed on 10th October 2020. Oh, 2024. Sorry, it's 2025 written there. So sorry, it's still need to come. But the aurora, the light has been blown up there due to that solar activity. And the first image is by the BBC, and other few images are by me. I was in Boulder here during that time, and I went outside. I took a lot of pictures there. Means specifically, truth to be told, this aurora was not clearly visible or with the naked eyes there in Boulder. All these things are like all these images specifically they are the by cameras. But if you go around the Alaska, Norway, there is a clearly blue sky. There is one famous Insta account, and he is my very good friend, Vincent Redvina, the Aurora guy. You can search it on Instagram. He posts pictures of all these aurora. He lives there in Alaska. He studies these aurora phenomena. So this is a beautiful thing that people observe, and I'm particularly working on the basic of these aurora. The aurora are the visible representation that are the beautiful one, but there are a lot of things happen in our magnetosphere, ionosphere. I am looking for that. You will see this is one of the simulation, actual science things that we did. Means if you look a sun from one of the side, means you have a sun here, and you have a sun here, and you have a earth here, and you are looking by the side, so you will see some structure is coming. That structure is passing our earth, and what will happen, how the equations of motion, how the charge particle will be there, and that comes with the simulation. You will see something is there, something is just fluctuating there but yeah, see the storm happens and how the things has been changed. If you compare the things back, you will see the color. The color codes are showing the pressure of plasma. Initially, it was at this point, but when the storm has happened, it just increases here. So the high plasma pressure get exerted on our magnetosphere. Here are the different quantities that are I showed you or I explained you about the current. These are the free these are the field aligned currents, and if you see before that the currents were there, but they were not in the big quantity. But when the storm happens, the currents are there, the currents are coming, the particles are precipitating in our ionosphere, specifically happening at our polar regions. So this is a real science simulation that I am been looking, and I am studying these October 24 storm, how the storm happens. I'm specifically working on the UT dependence. Means, is it matter that at what time the storm hits our magnetosphere? Is it matter? I'm looking for that. I'm doing my further studies over that. So another type of thing that I'm looking is it's a relation between the magnetic field and the disturbance. So people here in HAO called it as a Ghak conjecture, because they thought that it's my idea, so they just name it. So I'm still working on it. It's a relation between the magnetic field and the geomagnetic storm, a detailed relation there. So as my research is both in a magnetosphere as well as interplanetary space, as I am coming to US, I work on a magnetosphere, ionosphere, but in interplanetary, but in where when I'm there in my institute in Mumbai, I specifically work on the interplanetary space. You might see here the left side diagram. That's the diagram of a sun, and it is during a artificial eclipse time, means some sun is being masked by a or sun or an instrument that observes this, it been masked by some sort of artificial thing so that we can see the outer part. So you can observe a lot of a structure that is emitted from the sun, and when that structure emitted, it also propagates in an interplanetary space. And if you see the dimension, our Earth is like this, and its whole the structure here. And these are the particular parameters that we measure from the satellite that been situated just outside our magnetosphere. And I'm not going in detail with what it's actually there, but specifically, if you see here, something is coming from the sun. So here in University of Mumbai, I am observing this structure using spacecraft data, finding out the properties of I sir to sir Dr. Mirin sir just mentioned my paper there. It's about ICME, interplanetary coronal mass ejection. So whatever we are working in University of Mumbai is on ICME, and whatever I am working in the US here in Colorado is in magnetosphere, ionosphere. So I'm spanning that part. That's why I keep the interplanetary space, magnetosphere, and ionosphere. So I'm as I talk about it, as I give you the overall, but if you see, there are a lot of satellites that are revolving, and since 70 years we are not able to probe the actual, or we are not able to predict, understand what is coming from the sun. Yeah, we have quite good idea about, but we are still looking for a detail. And that's why we all have these kind of satellites mission. And all these satellites mission, we need people like you to analyze all this data. So as you see, the number of satellites are increasing, the number of opportunities are increasing. All these missions are there, they are proposed by NASA, JAXA. You will see our Aditya, or unfortunately, it's not here, but yeah, our Aditya, our India-based mission is there at this point, along with all these missions. This is specifically by NASA's satellites mission, and that's why it's not been there. And lots of satellites are here as well. So as it increases, you need people to analyze this data. You need a brain power to work on it. So all these happens here with this, and whatever I have explained is all about in the basic of sciences, or in the research, or in the domain of academia. But currently all the private startups are now there. You might heard about the SpaceX, and in 2021 the SpaceX, they had a loss of 20 satellites. Oh no, it's 40 satellites due to this solar storm. So everything there, a lot of, you see here, there is government initiative regarding these private startups in space-based space sciences, and you will see here a number of companies that currently, the Digantara one, which works for the satellite drag, means that I just explained there is a thermosphere. The thermosphere has a charged particles, and our satellites is moving around it. When such solar storm happened, this thermosphere this thermosphere uh, quantities, or this thermosphere structure, it changes, and due to change, our satellite got some drag, and due to that drag, they might change their path. So everything is there. So people are calculating what kind of drag has been observed by this satellite. And it's not up to the satellites, it's up to the aviation. People who are in the space, people who are in a flight, they are also receiving receiving some kind of radiation dose, and it is observed that there are studies during this storm. There is a change. There is a dynamical change on in this radiation dose. So there are opportunities either in a space or either in a academia or in a private sector. These are the two ways. You need some kind of educational background for it. So for working in the space based startups, you at least need a master of science, either a bachelor of science with something experience of coding, because everything we are working is on the data, and that data we can't handle by one-to-one basis. So we need a programming, we need Python, we need C++, we need Fortran, we need computers, we need engineers. So the thing, the one satellite mission, a one science program brings up a lot of opportunities, a lot of jobs. But you need some kind of educational qualification that I as explained for these, particularly for these startup based companies. You need either a master's, or currently they are looking for a PhD graduate. They are looking for PhDs who are who are available. And for the academia, you have to follow the path. You need to do your BSc, masters, or in US, or particularly, yeah, in particularly in US, you can be here or as a PhD student after you are undergraduate, but you have to do a lot of things. You have to do a GRE. While if you have a master's, then you have an advantage. You can come. As I mentioned, this is all about my group, and this is all people where they are in, particularly in my group. They all are different from the different batches. Out of these, lot of people are currently there in academia. Most of them are in US, UK. Few of them, they are currently working in companies like CDAC, a supercomputer companies, because they had a Python, or C++ uh, skills, and on that basis they had applied or they did some courses, and they are there. You see few of the people are doing PhDs in a institute in India, including Indian Institute of Geomagnetism, that's there in Panvel. One of our student is there in ISER Kolkata. You will see this is a current batch of students. They are pursuing their masters, and all these posters, they are contributed by these master students. And that's why I told you, all whatever I am showing, whatever I am, is not only by me. This is a cumulative effect by my supervisor, my current colleagues. And I am saying these are students, but they all are our colleagues, including a BSc students like you. I remember there was a BSc student from a college there in Mumbai. He is currently there in University of Reading, and currently he is there in a Princeton. He worked with our group during his bachelor's. So currently the opportunities are there. You need to knock it. You need to acquire that skills either in a programming, either in a basic physics. So this is what our group is currently doing in a field of space physics. The Center for Geospace Storm, I need to advertise, because whatever the models that I using is of this particular center. This is a center by US universities, including John Hopkins, Rice Universities, University of New Hampshire, and they are together building that particular models, and that I am working, that I am using. And yeah, this is about me. From the left side, it is a professional me, that whatever the institute I went there for the conferences, this is the things that about a NASA's heliophysics summer school. This is at a conference at NASA, a 4TD symposium. This is like a Kumbh Mela in science, AGU, American Geophysical Union. A conference is there, and I think this is at John Hopkins University. This is at my current institute, High Altitude Observatory, and this is all about the personal me, not a different one. How you people are, who love cooking, a pookie person who loves cat. Yeah, That's from my side. Thank you. And
Dear
I'm
student,
waiting for all questions. Yeah.
yes. Dear student, now session is open for question, and if you have any question, you can raise. You can unmute your mic and you can.
Yeah. You can ask question in any of the language, Marathi, Hindi, I said. Yeah, anything. Or English, anything.
हेलो हेलो
Yes.
गुड मॉर्निंग सर। तो उसमें एक डायग्राम था जिसके अंदर आपने
Yeah.
पोलार पोलार कप्स करके कुछ लिखा था। तो
Okay, okay.
पोलार कप्स क्या होता है वो बताओ ना जरा।
Okay. Bata. Yeah, I think this is or not. This is. Yeah, probably I can explain the cusp from here as well. So the cusp is a region where you will see the magnetic field is going here from the day side. Uh, Here you will see a magnetic field at a night side, a region between both these night side and the day side magnetosphere is at the polar region, and we called it as a cusp. In more basic fundamental physics things, it is a region between a open magnetic field. I don't want to be there in a complex one, but in a simpler thing, it is a different, or it is a region between the day side magnetosphere and the night side magnetosphere, and it is at the pole of Earth. That's why we called it as a polar cusp. Where it was, yeah, it was here, a polar cusp. You can see here. This part is known to be as a polar cusp.
ओके सर, थैंक यू।
Yes, any student? Is there any question you can raise?
मैग्नेटोस्फीयर जो
student.
और इनर मैग्नेटोस्फीयर है, तो दोनों के बीच में मतलब कुछ रेंज का फर्क है, मतलब क्या किसमें ज्यादा मैग्नेटिक फील्ड ऐसा कुछ
Yes.
रहता है, कुछ होता है?
Yes, of course. 1 minute. I will show you. Yeah. So let me, yeah, I should open up my hide slides. Yeah. So this is outer magnetosphere, where why it is outer? Because yeah, it's outside. It is towards the sun side. So you can see a bow shock, a magnetopause, actual boundary of a magnetosphere. Then there is a region. Then you can see a cusp here. So that's the outer part. And here the magnetic field. Uh, I means if I talk about a nano Tesla, it is about 600, 700. I might be wrong with the numbers, but it's there. But in a inner magnetosphere, the magnetic field is so high. So that's why you have a plasmosphere here inside. A plasmosphere means a plasma that co-rotates our with our Earth, because the magnetic field is so high, it carries the plasma, it rotates around our Earth. So that's a plasmosphere. Then these radiation belt, inner belt and outer belt. Radiation belt, but they are consist of the particles. They are consist of the charged particles. Initially, they called it as a radiation belt because when they just got idea, oh, something is happening there, something is destroying us, so then they called it as a radiation. But later they understood that no, it's a charged particle. They are high energetic charged particle, but the radiation belt name is there. So that's the inner part. It has a high magnetic field. Yeah, the compared to the outer magnetic field, because you will see a basic structure in a magnetosphere. A basic thing about magnetic field is you might heard that where the magnetic field density is large, the magnetic field is large there. So in the inner magnetosphere, it's large. So that's why it's large there in the inner magnetosphere. And in outer magnetosphere, it's small, not that small, but compared to a inner magnetosphere.
ओके सर, थैंक यू।
Yes.
Sir, I would like to ask one more question. Very
Yes.
nice presentation, Kalpesh sir. Just a one.
Don't call. Who is talking? Dr. Seema, ma'am?
Yes,
Yeah.
sir. Yes, sir. Yeah.
Yeah, ma'am, you please don't call me sir. You can call me Kalpesh. Yeah.
Okay.
We work with Dr. Raghav, right?
Yes, sir. Yes, sir.
Yeah.
Yeah, he was there for means we are maybe the first batch of the masters under Raghav sir.
Yeah.
So just one question I will like to ask is about we say like in the Earth's, if we see the Earth atmosphere, we say like yes, now it is heating up, the temperature is rising up. So if we go to the space weather, how you will comment? Like you are studying now the space weather. So what you can comment in general, like whether it is the effect of all the radiations which we are using now. Currently, we are having everything like Wi-Fi, everything we are using at a high level. So is it affecting the space weather, or it is have the nil effect on it, or how it is changing? Like the pollution, in the sense of pollution, I just wanted to know, have an idea how it is changing the space weather also, the way it is changing the Earth's weather.
So nice question. Generally, it when I'm talk about the space weather as it's basically driven by the sun. But yeah, with the pollution, eh, we are doing something because we are sending a lot of satellites, we are sending a lot of things, and they are being there. It is called as a space debris. Space का कचरा बोलते हैं वो लोग इसको. So that's been there. But the effect of all these things on the space is quite different, and still people are doing it. I'm not saying it is a negligible, or I'm not saying it is totally or not there. Still might be there, but if you compare a number to number basis, the amount of radiation by the sun and the amount of radiation by by the whole the human based things, the amount of sun is so large. So the variation in that radiation is just masking up. It is not giving a feedback to the space weather. It is everything happening in our atmospheric basis. Yeah.
Thank you,
I
sir.
hope I gave a clear answer. Yeah.
Yes, yes, sure.
Yes, anyone? Yes, dear student, if you have any question, you can unmute and you can raise. Okay. I think there is no any question from student side. Then I will go for vote of thanks. Sima ma'am, can I? Dinesh sir?
Yes, sir, surely.
Yes, yes. Okay. Good morning, everyone, except Kalpesh, because I think what is time, Kalpesh, there?
I need to. It's 12 Sawabara.
Okay, that
12:50.
is the good night. Good night for Kalpesh. And dear student, it is my privilege and honor to propose the vote of thanks for today's enlightening session. And on behalf of our HSLC Collegiate Board, our management, our respected principal, Dr. Neha Jakhani ma'am, respected vice principal and HOD of physics, Namrata madam, vice principal and IQSC coordinator, Dinesh sir, Dr. Lakshman sir, Dr. Sima ma'am, Poonam ma'am, and support staff, and our dear brilliant enthusiastic students. I would like to express our heartfelt gratitude to Mr. Kalpesh for taking the time to share his knowledge and insights on what are the different opportunities in space science. And he also explained about what is the why we need to study basic or fundamentals of science, that which is related to physics, chemistry, mathematics, then coding, Python, then languages like C++, and our vice principal and IQC coordinator head, Dr. Denis sir, is taking Kalpesh is taking Python as well as C++, separate certificate course for our for UG as well as PG students. That is a nice initiative by our minister. And Kalpesh also explained in his session that is what are the different various career research areas in space agencies to innovations as well as in satellite communication, planetary science, and different types of research area. And I think as per my knowledge, You made complicated subject very, very accessible and exciting for our students, and also explain about what are the basic fundamental laws like Faraday's, Ampere, then the difference between magnetosphere, thermosphere, atmosphere, different layers of ionosphere, again thermosphere. Uh, and lastly, I am again a big thank you for motivating us to look beyond the skies and dream big. We hope we will try to collaborate with you, with your knowledge, as well as with your organization, if possible. And once again, a big thank you, Mr. Kalpesh, for your valuable time and for sparking curiosity in the minds of all those present for today's session. Thank you.
Thanks
Thank you.
for thank you for giving opportunity here.
Thank you,
Thank you for
Kalpesh.
bearing me.
I think
Yeah.
मला वाटलं आपण I think 2 वर्षापासून आपण ठरवत होतो की we
Yes,
will
yes,
arrange
yes,
your lecture on
yes.
space physics.
Yeah.
आज योग आला. Thank you. Dear student, thank
But
you
sir,
so much
Thank
for
really,
your
yes, the presentation was really good.
superb.
We just
Yes.
from Tukaram to Pokemon and Pokemon to
you.
Sun and
and
Earth. What a link!
and
The vast presentation in a very short time, and to get connected with the
yes.
students, really a nice base you made, and really the
सीमा
nice
मॅडम अचानक
presentation.
रात्री आमचं I think 11:45 ला लेक्चर फायनल डिसिजन
Oh,
झाला.
and still the
Yes.
presentation was so
Are you
good.
with
It
Kalpesh?
was
Yes,
connecting
sir.
with the student.
Yes, within short span of time हे सगळं अरेंज झालं and we will try visit to NASA also with our
Yes.
students.
Yes.
त्यांच्या
And
जवळ
Very
if
well,
you,
very
I
well.
my things are here. My email ID is here. If you
Yes,
want
yes.
anything,
Yes.
anything, you can reach to me. Yeah,
Yes.
anytime. Any kind of help with any kind of research project that you want, or with the university, with department. Yeah, we are there. Yeah.
Yes. If there is any query, I will share with you via or
Yeah.
WhatsApp group. Okay. And again,
Sure,
thank
sure.
you. Thank you so much, Kalpesh. Thank you.
Thank you, Kalpesh sir.
Yes.
Thank you.
Yes. Thank you. Yeah.
Yes, Shwan, thank you so much. And
Thank
now
you,
we
Kalpesh
will
sir.
end this session.
Yes. Thank you.
Thank you so much, students, and good night, Kalpesh.
Yeah.
Good night, Kalpesh.
Yeah. Thank you.
Sir, we can end the meeting now.
Yes, sure. I'm ending. And I'm ending
Yes.
this session. Thank you again. Thank you so much.